Thank you all for watching this video. Many hydropower turbines have high upfront costs and maintenance makes them unfeasible. The focus of my project is to create a cheap cold cure epoxy coating with different fillers to apply to stainless steel turbine blades. I got the idea because I worked with coatings in my 7th grade science project when creating a non-toxic fire-resistant coating, and wanted to apply knowledge I learned in high school physics to blade coatings. I evaluated them with 3 properties: erosion, pencil hardness, and adhesion retention to create a composite score. GNP1 had the lowest mass loss, while GNP1 SC6.5 had the highest mass loss. Graphene nanoplatelets are good at distributing stress due to the ring of carbon atoms, possibly decreasing microfractures. However, when round silicon carbide particles were mixed with flat, slippery graphene nanoplatelet sheets, the solution might have become inhomogeneous, leading to weakness. An ANOVA revealed statistical difference in coatings, while a bootstrap resample was done in C++, showing statistical significance for 10,000 resamples. Silicon carbide had the highest hardness before and after erosion, but didn't have the lowest mass loss, illustrating that high hardness particles don't always perform the best in erosive conditions. One challenge in analyzing the pencil hardness data was that the range is non-linear, making many statistical interpretations difficult. This is why a dot plot and the Kruskal-Wallis test was used. Silicon carbide also had the highest adhesion through crosshatch testing, though more trials are necessary to confirm. One challenge was mimicking the erosion conditions in a home lab. I tried to use a power washer since nozzle testing is the norm for slower erosion, but this produced little to no damage. Next, I tried an ultrasonic cleaner to produce exploding cavitation bubbles, but as this is mostly used for biofilms, my ultrasonic bath was just not strong enough, which is why I had to switch to a rock tumbler. Instead, I justified similarities in the rock tumbler to wastewater conditions by calculating Freud number, showing high centrifugal force and impact, and Reynolds number, showing turbulent impact behavior. Another challenge I encountered was consistently pouring the epoxies since they are so viscous. I switched to disposable syringes to increase accuracy and reduce losing material within transfers. Going back to the results, after doing a thickness loss estimation, you can see how much the GNP outlasts the others in time to full erosion in days. In the future, I hope to coat a real mini hydropower turbine to assess experimental power differences and compare them to the turbine power equation. I had so much fun doing this project, and I encourage you to flip through my project pictures, raw data, ANOVA tables, or full paper shown.